Good afternoon, dear student. Today I am going to discuss about the new topic application of first law of thermodynamics. कल मैं पहले ही बता चुका हूँ कि according to the first law of thermodynamics, delta U is equal to Q minus W, where delta U is the change in internal energy of the system, Q is the amount of heat taken by the system, and W is the work done by the system. So already I have discussed this topic in the previous video. So now today I am going to discuss about the application of the first law of thermodynamics for the different processes here. First one is what here, cyclic process. As you know, a cyclic process is that process in which a system, after passing through the different states, finally come back to the initial state. अगर कोई सिस्टम एक स्टेट से दूसरे तीसरे स्टेट में होते हुए और फाइनली वो उसी स्टेट में जो वापस आ जाता है, तो दैट प्रोसेस इज सेड टू बी साइक्लिक प्रोसेस. जैसे मैं बताया था कि सपोज इफ ए सिस्टम मूव्स फ्रॉम स्टेट ए टू स्टेट बी and finally return from state B to state A. So this process is said to be what process here? Cyclic process. And in cyclic process, since the initial and final point is same, the start यहाँ से हुआ होते हुए फिर वापस यहाँ पे आ गया, तो internal energy or change in internal energy, you know delta U is always equal to U final minus U initial, and derivative U final minus U initial. So here final and initial both are same, so you can say delta U is equal to 0. It means in cyclic process, the change in internal energy U is equal to 0, and when we apply the first law of thermodynamics, delta U from first law of thermodynamics, delta U is equal to Q minus W, and when delta U is equal to 0 for the cyclic process, so G U is equal to Q minus W, or we can say Q is equal to W. Q is equal to W means in the cyclic process, the amount of heat taken by the system is completely used for the work done. So this is what here application of the first law of thermodynamics in the cyclic process. Similarly, we can apply for isolated system. So second one is isolated system, and in same way like the cyclic process, suppose second one isolated system, isolated system, and in isolated system is that system in which system neither takes heat nor do the work. Isolated system वो system है जिसमें system ना तो heat लेता है और ना तो work होता है. Neither takes heat means Q is equal to 0, nor do the work means W is equal to 0. And from first law of thermodynamics, from first law of thermodynamics, delta U is equal to Q minus W. So Q is equal to 0, W is equal to 0. You can say here delta U is equal to 0. It means in isolated system, the change in internal energy of the system is equal to 0. So in this way, first in the cyclic process, when we apply the first law of thermodynamics, Q is equal to W. In isolated system, when we apply the first law of thermodynamics, then Q is equal to 0, W is equal to 0 means neither system takes the heat nor do the work. And in this case, you can say Q is equal to 0, W is equal to 0. So from first law of thermodynamics, delta U is equal to Q minus W, or delta U is equal to 0. So change in internal energy is equal to 0. Third one is isobaric process. As it is clear from its name, isobaric process is that process in which the pressure of the system is remaining constant. So third one, isobaric process, isobaric process. And remember this, isobaric process is that process which takes place at the constant pressure. For example, boiling of water in heat engine, steam engine. Second, freezing of water. Third, boiling or formation of the gas or boiling. Means all these takes place in what here at the constant pressure. Or simply you can say isobaric process, the example of which freezing of water and formation of steam boiling of water in steam engine. All these are the example of what here isobaric process here. And suppose if we will take m mass of liquid, and suppose the m mass of the liquid is heating here in the form of or boiling in the form of steam. So initially it was in the liquid form, then its volume was VL, and finally it changed in vapor of volume V. So suppose Q amount of the heat is given to this liquid, then M mass of this liquid is changed from liquid to vapor. So amount of the heat given to this Q is equal to mL, where M is the mass of that liquid and L is the latent heat of the transition. So Q is equal to L. And from first law of thermodynamics, when we use the first law of thermodynamics, delta U is equal to Q minus W. So you can say here delta U is equal to Q means mL, and as you know W is equal to P into delta V, and since isobaric process occurs at the constant pressure, so we can say here W is equal to P delta V means change in volume. Change in volume is final volume minus initial volume. So final volume is volume of vapor minus volume of liquid. And in this way, you can say delta U is equal to mL minus P VE minus VL. Or from here we can say mL is equal to delta U plus P VV minus VL. And this equation represents that the heat given to that liquid is used for, a part of it is used for changing its internal energy, and rest amount of the heat is used for doing the work against the external pressure. So in this way we can apply the first law of thermodynamics for the isobaric process. Next one is isochoric process. As it is clear, isochoric process is that process which takes place at the constant volume. So next one, isochoric process. Isochoric process. And isochoric process is that process in which the volume of the system is remain constant. And when volume constant occurs at constant volume, constant volume. So we can say here, if it occurs at a constant volume, it means delta V is equal to 0. And when delta V is equal to 0, then work done W is equal to P into delta V is equal to 0. And from first law of thermodynamics, when we apply the first law of thermodynamics, delta U is equal to Q minus W. So you can say here delta U is equal to Q minus W is equal to 0. So delta U is equal to Q. It means in isochoric process, delta is equal to Q means the amount of the heat taken by the system is used only for changing its internal energy, and in this process the work done will be equal to 0. Next one, similarly for the isochoric process, isothermal process. And as it is clear, first one, isothermal process. Isothermal process. So isothermal process is that process which occurs at a constant temperature. Occurs at constant temperature. And isothermal process is that process which occurs at a constant temperature. और अगर temperature constant है, तो remember this, for an ideal gas, the internal energy is depends only on temperature. किसी ideal gas के लिए उसकी internal energy केवल temperature पे depend करती है, और यहाँ temperature constant है, इसका मतलब उसके internal energy में कोई change नहीं होगा. And in this case, the change in internal energy U is equal to 0. And when we apply first law of thermodynamics, delta U is equal to Q minus W. So you can say delta U is equal to 0 is equal to Q minus W, or Q is equal to W. Q is equal to W means in isothermal process, the heat given to the system is completely used for the work done, and in this case, the change in internal energy is equal to 0. So this one is the isothermal process. And last one is adiabatic process. As it is clear, in adiabatic process, adiabatic process. And remember this, adiabatic process is that process in which neither system takes the heat nor leave it. न तो सिस्टम हीट लेती है और ना तो देती है उसमें. It means in this case Q is equal to 0. So adiabatic process is that process in which the system neither takes heat nor leave it. So Q is equal to 0, and again when we apply the first law of thermodynamics, so delta U is equal to Q minus W. So delta U is equal to 0 minus W. It means delta U is equal to minus W. It means change in internal energy is equal to minus W. In what case? In the adiabatic process. Now we know work done on the system and work done by the system. So under adiabatic process, remember this, work done on the system, work done on the system is always negative. And when we consider the work done on the system, so in adiabatic process, when work done on the system, the change in internal energy delta U is equal to minus already here, and at place of W will take minus value of W. It means this becomes plus W. It means in adiabatic process, if work done on the system, then it will increase the internal energy of the system. वो system की internal energy को क्या करेगा? बढ़ा देगा. और work done by the system, work done by the system is considered positive. So in this case, delta U is equal to minus plus W. It means delta U is equal to minus W. ये दोनों चीज क्या बताती हैं? Under adiabatic process, if work is done on the system, then delta U is equal to plus W. It means the internal energy of the system will increase. While under adiabatic process, if work done by the system, then change in internal energy becomes negative, and it shows that the internal energy of the system you want here decreases. So, dear students, today all of you go through this topic, what I have discussed here, and in this way, your this topic is completed. Thank you.